Okay, looking at example number 5, we're now dealing with transformations on the graphs of sine, cosine, and tangent. Okay, it's very important to know what these base graphs look like. So just to review the basic graph of sine, you're going to have to go back and review cosine and tan. Okay, sine starts at its halfway point. It goes up to its max at 1, then down to its minimum at -1, and back to half. Okay, it has x-intercepts at 0, at 180, or pi, and at 360, or 2 pi. It reaches its maximum at pi over 2, and it reaches its minimum at 3 pi over 2. Knowing the characteristics of this graph is very important. So in comparison to this graph, how is this transformation affecting it? Okay, so just looking at the basic transformation notation. Okay, A stands for our amp. B stands for our horizontal stretch factor. That's going to change our period. Okay, C is our horizontal phase shift, how we're moving left or right. And D is our vertical displacement. Okay, amp is literal. Whatever your A value is, that's what it is. So amp here is 2. Okay, we can also describe it as a vertical stretch of 2. Our horizontal stretch will always be reciprocal, 1 over 3. Okay, but how is that going to change the period? Well, the formula for a period is 2 pi over b. Well, our b value is 3. So the new period will be 2 pi over 3. If you think about that, 360 degrees, if we compress it by a third, okay, third of 360 is 120 degrees, which in radians is 2 pi over 3. Horizontal phase shift, that comes from our C value. We are moving right pi over 3 units. Okay, or 60 degrees. And then lastly, our vertical displacement is -1. Okay, that means we're going down 1 unit. So just to see visually how these two graphs compare, I'm going to put this into my graph, and we're going to look at those changes. Okay, first you want to change your window settings. I'm going to deal with degrees, so 0 to 360. I'm going to scale up by 30 degrees. Okay, let's make our y min -2, our y max 2, we'll scale up by 1. Make sure your mode is the correct mode. I need to be in degree mode if my window settings are in degree. And now we can graph it. So let's just put in sine x to start. This is the base graph. And then we're going to compare to the transformed graph, which is 2 sine 3, close the bracket, another bracket, x minus pi over 3, close the brackets, and then we're going to subtract 1. Take a look at the graph. This is the base graph right now of sine x. Okay, and this is the transformed graph. How many more times frequent is it occurring? Well, 3 times as many, because it's compressed by third. So that means within the same domain, it's going to occur 3 times as much. That also means that we're going to have 3 times as many solutions within that same domain. Okay, we can also use technology to solve trig equations. For example, we have 4 sine 3x equals 6 plus 5 cosine 3x over the domain 0 to 2 pi. We already have our calculator set up, so we just need to put in our new equation. Okay, it might be useful to just move everything to the left-hand side and find our x-intercepts. so I'm going to put everything to the left-hand side. 4 sine 3x minus 6 minus 5 cosine 3x. Now we can graph it, and our solutions will just be the x-intercepts. So if you get a graph like this, troubleshoot. My problem is my mode. I didn't change it to degree mode. So that's why I'm getting this wonky graph. So I gotta let it do its thing. Let it do its thing. Change the mode to degree. Okay, try graphing it again. There we go. So I have 1, 2, 3, 4, 5, and 6 solutions. So let's just draw those. Now, as you can see, they look evenly spaced out, and if you were to actually calculate the x-intercepts, I'm just going to go ahead and write them down because I've solved for the first 3 ahead of time. Okay, we have 40.3 degrees, we have 53.9 degrees, we have 160.3 degrees, and I'm just going to stop there and take note. Okay, the difference between 40.3 and 160.3 is 120 degrees. Okay, the same thing's going to happen for the next jump. Okay, going from here to here will be 1 period, so 120 degrees. And I'm getting that 120 degrees because of the b value. The new period will be 2 pi divided by 3, or 360 divided by 3, which is 120. Okay, so if we're asked to find the general solution, I know my general solution will be 40.3 degrees plus 120 degrees times n, as well as 53.9 degrees plus the period 120 degrees n, okay, where n is an element of integers. That is your general solution. If you're asked to find all the solutions, then you just need to trace these x-intercepts on the graph. Okay, second trace number 2, 0.